All right, let's see if we can find a flux through a plane with f is zk. So my plane goes through the points 0, 0, 0, 1, 1, or 1, 0, 0, 1, 1, 3, and 0, 1, 3. We already do this one?
No.
No.
At least
If
not
we
with this
did-
player.
If
All right.
we did, we didn't finish.
If we did, we didn't do a good job.
We got kicked out of the other room,
Yeah.
and you threw some
Yeah.
jazz at us about negative
So-
f of x, negative f.
I would like to think of that thing as a function of x and y, right? Because I have this new toy. Do you all remember the new toy?
No.
Okay, let's go back and remember the new
Okay.
toy then. So the new toy is that d area thing.
Normal vector.
Yeah, it's a normal vector, right? Times regular d area. This normal vector being unit length. And then if you rigmarole this around a little bit, last time we found out that we could put down, what was it? Minus fx, comma, minus fy, comma, 1. Hi, Henry.
He doesn't really like doing pat, does he?
Likes to be
scratched.
Yeah.
He's looking for food.
Okay, so I could put this down as my normal vector and do d,
X, y.
yeah, x and y. Right. Okay, so this came out of some stuff about taking a cross product between some bits and pieces and remembering something about parallelograms, right? But maybe let's just take that as an alternate expression of d area. Okay, so now if I could find f of x and y for this plane, right, then I could just use my new toy. So what's f of x and y? So I want to find a plane equation, right, for this business. So if I go over 1 in the x, what happens? To the z,
Oh.
right? Over 1 in the x causes
No change.
nothing in the z, right? Okay, so I'd like to think about this as, okay, so there's 0x slope. Now what's my y slope? If I go over 1 in the y, what happens to the z? Goes up 3, right? And then what's the kind of initial z value? 0, right? If I plug 0 in for x and 0 in for y,
Jeez.
I know that I've got the point 0, 0, comma, f of x and f of 0 and 0 gives me 0. Okay, so I managed an equation for this plane. It's f of x and y is 3y. That was actually a little overkill, right? Right? So now what? Yeah, I gotta take some partials. So I need the partial of f with respect to x. That's gonna be 0. Partial of f with respect to y is 3. Okay, and then I need to put them in here, right? So I should be doing, all right, I'm going to take the integral over a surface f of f dotted with d area, right? And I'm going to say, okay, I'm going to do a double integral, right? I'm going to trade d area for what? dx dy. And what's 0, negative 3, 1. Okay, now what goes here?
0, 0, z.
0, 0, z. Where'd you get that?
F, it's just zk.
F, z, k, right? So I'd like to put in 0, 0, z. However, why wouldn't I put in 0, 0, z?
Because it's there.
Oh, yeah, okay.
Yeah, I should get a number up, right? If I put a z in there, what am I going to get out?
Z.
Some function of z. So what's z?
3y.
Perfect. Z is 3y from this. So I got 0, 0, 3y that I'm putting in. And now where do the x's range?
0 to 1.
A picture, they go from 0 to 1. And where do the y's range?
0 to 1.
Also 0 to 1. Perfect. So once I do the dot product here, I've got the integral from 0 to 1, the integral from 0 to 1 of what?
3y.
Perfect. 3y dx dy. Guys with that?
Just 3y from 0 to 1.
Okay, so I got integral from 0 to 1 of 3y dy times the integral from 0 to 1 of dx. Which is exactly what you said, I think. So this piece is 1, so we can forget it. So I get, what? 3 halves, seems like. Cool. Questions, things? We should spend a second talking about orientation here. Is this the flux going through the surface that way or through the surface this way?
We're measuring the unit vector up, however.
Yeah, so I formulated this thing by taking the x partial and crossing it with the y partial, right? So that's a, by the right-hand rule, thing that sticks up out of this. So I'm taking the flux that goes up through this. You guys see that? So the total flow through this thing is 3/2 units, and that's a tendency to go up, right?
So we can look at the sign of the Z, the one, right? Not the, sorry, in the alternate dA form down. If that's positive, then it's up. If that's negative, then it's down.
Yeah, although this one is, really this is just an alternate expression for T area, right?
But if we cross it the other way.
Yeah, so if we had done the y partial cross with the x partial, we'd get fx, fy, -1, and we'd be talking about the flux down through this. Yeah, so that's an important consideration, right, that I haven't really made a huge point of. These things have a direction. These ones go up through the function. They always rise through if you're using this. Otherwise, you get to kind of pick that orientation. Cool? Thanks. Questions on that?
Are we gonna have to figure out like it's always pointing straight up or pointing straight down, or are we gonna have to figure out kind of a angle so that way it's like at a that it's a
Yeah, so what this means is this is the amount of stuff that's passing through this surface. And I drew this sticking straight up, right?
right.
And that was really bad drawing on my part. What I really mean is that normal vector, right, that I'm talking about here, this guy, that sticks perpendicular out of this thing.
It does, okay.
And so what I get is the total flux through this thing.
From the bottom.
This thing flows straight up. See that?
Yeah.
So I've got a vector field flowing straight up, and I'm asking how much of that's making it through this screen.
So does it matter at what angle that it passes through it?
Yeah.
Okay.
So if this thing was pointed straight up and my plane was pointed kind of up and down, right, then nothing would be going through because it'd all be flowing right past.
Okay.
But if I tip it a little bit, then it starts to go through a little more.
Okay.
And that's why we're taking that dot product with this normal vector, right? We're saying, how much does the flow direction, this guy, agree with the sticking out of this thing direction? Cool?
And that field flows more up the higher you go.
Yeah, and this field specifically flows up faster the higher you go. And so most of that flux, right, is probably coming from up in here, and much less of it from down in here. Cool?